Hello there, welcome to this video on graphing sine and cosine with phase shifts. Finally, we're going to have the whole enchilada, the whole gamut, everything, A through Z with these sine and cosine functions. We're going to teach you how to go ahead and add a horizontal translation. We're going to start doing this to our graph. All right, are you ready? Are you excited? I knew it. I knew you're here for a reason. All right. So prior knowledge, let's go ahead and just first kind of recap. Where does a sine and a cosine function start? At what point? Very good. The sine and the cosine function will start, the sine function will start at the midline, and the cosine function will start at the maximum. Unless there's a reflection. Yes, I know you knew that. Good job. Just checking to make sure. All right. Again, we're graphing sine and cosine today. Just a recap on some terms. The period of a sine or a cosine function, usually 2 pi, right? And this is the length for one cycle or for one wave to start to repeat itself. Amplitude, that is the distance from the midline to the max or the min. Okay, and if you're just kind of calculating it without a midline, you can take the distance from the max to the min, subtract those, divide that by 2. That would also be your amplitude. The midline, remember, is the halfway point between the max and the min, like I just said, and that is indicated by your k value in your function. Okay, so those are just some kind of short recap and visuals on period, amplitude, and midline. I don't know why I froze there for a second. Completely forgot. All right, so transformation so far that we have learned. We're going to go ahead and add in the horizontal translation. This is what we call phase shift. Can you say phase shift? Good job, okay? And when there's no horizontal translation, the phase shift is said to be 0. And that's kind of what we've been working with so far, okay? Again, horizontal stretch or compression, that's period change. A vertical stretch or compression, that's indicative of your amplitude. And then a vertical translation will occur because your midline is changing, okay? And again, we do have to worry about reflections. But we're pros. We've done this a million times. All right, so again, given our general forms, for these functions, remember our period is 2 pi divided by 1 over b. So if I have a coefficient in front of the x in the argument, we have to divide the 2 pi by that value. And then adding in phase shift. So phase shift is now going to be represented by this c value here in your function, okay? And just like horizontal translation for other functions, we expect to see subtraction, x minus a value, okay? So it's kind of always the opposite. So if you see x minus pi, we're going to the right pi units. If we see x plus pi, we're going to the left. So kind of watch for that, right? It's always the opposite sign. And then something we also have to worry about is our phase shift gets affected by a period change. So the first couple of examples we'll do, we won't have a 1 over b. We'll just see a c value. But what we have to go ahead and do is we have to factor out that 1 over b value, or we can just merely divide by the 1 over b to give us our proper phase shift. Okay, and I know you're like, what? A, B, C, D, E, F, G. What is all this? It'll make more sense here in a second when I show you some concrete examples. Okay, so again, in order to graph sine or cosine, we're going to determine the period, amplitude, midline, and now phase shift. Here's the new learning for this lesson, the phase shift. And again, our scaling. It's recommended that you use pi over 4 or take your period and then divide the period by 4. Step 3, mark the points at the beginning and the end of the period. Unless it's not possible, then you'll have to adjust on the fly. Extend the cycle as needed, far left or right, and then draw a smooth curve. Smooth. All right, let's go ahead and check out an example. Here we go. I promise this monster is not too ugly, just a little ugly. Period. All right, so we want to go ahead, find the period, midline, amplitude, and phase shift, and then graph this function. So g of x is equal to 2/3 sine of x minus pi halves. So the first thing we're going to look at is our period. And remember, our period is 2 pi divided by 1 over b. And our 1 over b value in this case is just 1. So I don't have any period change. I just have a normal standard period. Amplitude. Amplitude is indicated by the absolute value of your a value. So I have 2/3, which is approximately 0.67, okay, or just 2/3 if you want to be precise. Our midline, this is our k value, again, added on at the end, which we don't have one here, so it's 0. Okay, and then our phase shift, So our phase shift is indicated by our c value, which is here. Okay, so I'm going to the right, pi over 2, and we're going to divide by our 1 over b value. Well, again, in this case, I don't have a coefficient in front of that x, so I'm just dividing by 1. So our phase shift is only pi half units. Okay, and again, this is going in the direction right. All right. Let's go ahead and graph this. Let's see what this horizontal translation does to our graph. So I have my midline. Let me get my snail lines going here. Okay. And then what I'm going to do is I'm going to graph my beginning point. So my beginning point. This is a sine function, so normally I would start the parent function at 0, 0, but we have a phase shift. We're going right pi halves. So I'm going to go right pi halves. So here's the first point. Okay, and again, I'll kind of recap. This is a sine function, so we start at the origin, but our phase shift, this is a horizontal translation. We're going right pi over 2. So I have my pi over 2 here. And then I'm going to go ahead and repeat. Our period is 2 pi. So every 2 pi will repeat. Okay. So there is your function, the beginning and the end. And then we'll go ahead and just kind of cut that in half. So for a sine function, I'm going to have a midpoint there. Back on my midline. And then in between, it looks like at pi, and then at 2 pi, we'll have our max and our mins. So our amplitude is 2/3. So it's going to be roughly right here. Okay, and then for our minimum, about 2/3, roughly right there. Okay, so here is what one cycle of our function looks like. Okay, and we can just go ahead and repeat this if we can. I don't know if we have enough room over here, so I'm going to have to go back to this one. Okay, so pi over 2, pi over 2, pi over 2. Almost are able to repeat it. Okay, and I'll add an arrow there, and then we'll extend left. So one cycle here. Right. And then again. Okay. There we go. And again, this should be concave, kind of up, opening upwards. And then I'll change now, kind of opening downwards, opening upwards. There we go. There is the graph. Okay, so that's the phase shift. The only thing that, that changes, right, is I'm just starting. I'm going right pi half units. Okay, and then I just repeat again. So it's exactly the same, just with the horizontal translation. Let's look at a second example. Here we go. So they say find the period, the amplitude, midline, and phase shift, and then graph the function. So we have g of x is equal to negative cosine of x plus 3 pi over 4 plus 1. So we got a lot going on here. First, period, 2 pi divided by 1 over b. Well, our 1 over b is just 1, so, no changes there to our period yet. Our amplitude, absolute value of our a value. So -1 is the a. We will have a vertical reflection, but our amplitude is still just 1. Our midline is our k value, so y is equal to 1. And then we have a phase shift, okay? So our phase shift, our c value here is -3 pi divided by 4. Okay, divided by 1 over b, which, okay, in this case is just 1. So -3 pi over 4 is our phase shift. We're going left 3 pi over 4, okay? Remember, so our h value is always the opposite. Well, in this case, we call it a c value, but tomato, tomato. All right, let's go ahead and graph this. So I'm going to plot my midline, which is at 1. So we have a vertical translation up 1 unit. Shift it up 1. Okay. And then I'm going to plot my beginning point and then my end point. So I'm going left 3 pi fourths units. So from, again, I just kind of think about this from my midline. So I go left 3 pi fourths. Okay, but this is a cosine function. So cosine function is normally going to start at the maximum. All right, and added to this, we have an a value that's negative. So we need to go ahead and reflect. So instead of starting at a maximum, I'm going to start at a minimum. So I'm going to go down 1 value. So here is my starting point. Okay, again, I translated left 3 pi fourth units, and then instead of starting at a maximum, I started at the minimum. Okay, and our amplitude is just 1. So every 2 pi, this is going to repeat. So that would be 1 pi, here's 2 pi. Okay, and then halfway between, we're going to have our maximum. Okay, and in between that, we will have our midline points. So there we go. And then here is 1 wave or cycle. Okay, there you go. So now we can just go ahead and repeat that. Before I repeat that again, I kind of want to go back over kind of what I did. Again, our midline's at 1. I have a phase shift left pi, or 3 pi fourths. So I'm going to go left 3 pi fourths. And then since it's a cosine function, instead of starting at the maximum, we have our reflection. So I'm going to start down here. Okay. So that's the phase shift. And then the rest of this is, what we've been used to. So go ahead and then plot the rest of these points, right? So we have a midline point, a maximum, a midline point, a minimum, midline, max. Okay, mid, max, mid, min, mid, max, and then ending at a mid. Oh, this one's off. I got off over here. Why don't you guys say anything to me? Mid, this one's off. Not too bad. Right here. Okay. There we go. Okay. Maybe you did. Maybe I heard you. That's what it was. You were telling me. Schwarberg, you messed up. All right. there is our graph. Beautiful. It's so pretty. I love it. I made it myself. They call me Mika Schwarberlo. That's my made-up Italian name, I guess. All right. There's a period. There's the phase shift. Okay, without period change. All right. So here is a practice problem. Please pause the video. Try this. Give this one a go. And I'll be back really quickly to talk about the period, amplitude, midline, and phase shift. All right, hopefully you went ahead and tried this one. Again, we don't have a 1 over b value, it's just 1, so your period's going to be 2 pi. The amplitude is the absolute value of -5/2, so your amplitude should be a positive 2.5. Your midline, we don't have a k value, so you're just centered on the x-axis, and then our phase shift is pi. And we're going to write pi units, okay? So hopefully you got that. If you made any errors, pause the video, adjust, and then I'll show the answer here in a second. All right, here is the solution. This is the solution. Wow. We're going to write pi radians, so we're going to start here, okay? We do have a negative a value, so you have to go down to your minimum first, okay? And then your amplitude's -2.5. So this distance, right, should be 2.5. All right, and then the rest is very, very straightforward. Okay, you guys ready for it to get heavy? Here we go. So now we're going to go ahead and look at a function where we have period change and phase shift, okay? And just a note about this problem, I'm missing an x here. They should, oh wait, no I don't. It's in the numerator. Okay. Thought I caught a typo, dang it. G of x is equal to -2 sine of x over 2 minus pi fourths. Okay, so our period's going to be 2 pi divided by 1 over b. So divided by 1 over 2. Well, this is 2 pi multiplied times 2. So our period is 4 pi. 4 pi's. Amplitude. Amplitude is indicated by the absolute value of your a value, -2. So our amplitude's 2. We do have a reflection, so we have to make note of that. Our midline, whatever k is, and in this case k is 0. So we're centered on the x-axis. And then phase shift. Okay, so here's where it's different, so make sure you're paying attention here. Maybe just watch for a second. I'll let you type here in a second. Or write this down. So our phase shift, our c value is pi fourths. All right, I'm just going to write this first. So c divided by absolute value of 1 over b. So our c value is, dang it, forgot, pi fourths. Divided by the absolute value of our 1 over b, and our 1 over b value was 1/2. Okay, so we divide those two values, and so what we get is pi fourths multiplied times 2. So you can cross reduce, or you can go ahead and multiply and then reduce, so 2 pi over 4, which is just pi over 2. So our phase shift, we're going right pi halves, okay? All right, so we found our phase shift. We're going to go ahead and graph this. Now, before, I want you to kind of think about this as another way of doing this, because we've seen this kind of situation arise before. If I have an a value that's -2, and then my function, sine of, I'm going to factor out that your 1 over b value first. Isn't it 1/2 times x minus, and then here I have my actual phase shift, your actual h value. Okay, so this is pi over 2. Now, you don't have to write it this, and if this is going to confuse you, don't worry about it, but maybe try to think about what I'm saying here. is if I'm factoring out that 1 over b value, that's going to reveal your actual h value, your horizontal shift, your actual phase shift. And because I factored out, I pulled out, right, which is division. I'm pulling out a 1/2, a GCF of 1/2, really. That's going to affect this c value, the pi fourths, right? So I'm dividing that by 1/2, which is literally what I'm doing right here, right? Pi fourths divided by 1/2, and then that gives us our actual phase shift, our horizontal translation, pi over 2. Okay, so you can think about it that way, but I think most of our problems will be set up this way to where you don't have to rewrite the function. Okay, but just some commentary there. Okay, let's go ahead and let's graph this. If you're still with me, if you're still watching. So I am going to go ahead and graph my midline. We're at 0. Okay, there's the midline. And then I'm going to go ahead and graph now the beginning and the end points. So my beginning point, this is a sine function. So I'm going to start on the midline. And my period is 4 pi. But I do have a phase shift right pi half units. So I have to go right pi over 2. Okay. Pi over 2, which, you know, I almost have something that's nice and even. I'm kind of short 1 pi fourths, so I'll just put it there. That will kind of help us out. Okay, and then I'm going to go ahead and cut this in half, so that will give me 2.25. There's our other midline. Okay, now I need to cut that in half. That's either going to be normally my maximum, but I have a vertical reflection. My A value is -2. So instead of going up 2 units, an amplitude of 2, instead of going up to a maximum, I'm going to go down to a minimum right here. Okay, and then that means in this area of my graph, I'm going to go up to my maximum. Okay, and so there is one cycle of my graph. So I'm going to go down, smiley face, frowny face. Okay, and since we're kind of going off our graph, you can add an arrow there, but that's what one cycle would look like. Now let's extend our graph to the left. To the left, to the left. Everything we own in a box to the left. Do you guys like Beyonce? No? What's wrong with you? I don't think I'm doing this right. Hopefully you haven't been following my lead. I've been so distracted by singing to the left. I need to go over 1 pi. You know, really what I should do is I'm going to go to the left 1 period. So 1 period, 1 pi, 2 pi, 3 pi, 4 pi. So there's 1 cycle, or 1 period, okay? And then I'll cut that in half. That's going to be my midline. And then in between that will be my maximum. Okay, I think I got this figured out. Maybe. Okay, and then down here will be my minimum. All right. Okay, so there's another cycle. Can I fit in one more? I don't think I can. I'm a little short on it, but there we go. I'll just add this. Okay. All right, so there is our graph with period change and phase shift. Wow, you guys are awesome. Look at you. Look at you go. All right, let's look at another example just to kind of clarify this. All right, so now we have g of x is equal to 4/3 cosine of 4x plus pi plus 1. our period is going to be 2 pi divided by our 1 over b value, which in this case is 4, absolute value of 4. So we have 2 pi fourths, which is just pi over 2. That's a very, very short period. Okay. And then our amplitude is going to be 4 over 3. There's our amplitude, absolute value, which is just 4 over 3. Okay, and then our midline, y is equal to 1. It's our k value. And our phase shift. Our phase shift is going to be the pi value, my c value, here's c, divided by our 1 over b, which is 4. So we're going right, pi fourths. Okay, and we have a period of pi over 2. All right, so I'm going to go ahead and graph the midline, which is 1. Okay, and then I'm going to go ahead and graph our starting point. Our phase shift is, our c value is actually negative pi, so this should be negative pi fourths. Sorry, right? Always the opposite. So I'm going left pi fourths, which is just 1 unit here. Okay, and this is a cosine function, so I'm going to start at the maximum. I'm going to start at the maximum. So just so you can kind of track where I'm at. So I'm going left pi fourths, and then I'm going to have to start at the maximum, which is, our amplitude's 4/3. So I'm going to go up 1 1/3. So here will be my maximum. Okay. Our period is pi over 2, which is every 2 units, very, very short, which is this one, okay? So pi over 2, and then in between is going to be the minimum. So down 1 1/3. Down 1 1/3. Okay, and then in between will be the midpoints. All right, so just kind of recapping what I did is I drew my midline, and then I was going to pick my starting location. So I went back pi fourths, because that's our phase shift. So using the phase shift, horizontal translation, left pi fourths. And then this is a cosine function, so I'm starting at the maximum, which is 4 over 3. So 1.333 is your amplitude. So up. Okay, then my period is pi over 2. So every pi over 2, which is 2 pi fourths, I'm going to repeat, right? So every 2, what we have as units are going to repeat. Okay, and then in between is our minimum, and in between that is our period. So here is 1 cycle of our function. Okay, and I'll go ahead and kind of repeat this. So I have minimums here and here, okay, and then midpoints. So it's almost kind of a pain in the butt when you have a very, very short period. Okay, so graphing this out. There we go. And I'll just finish this half of the graph. Okay. So I'm just plotting my period, and then halfway between is a midpoint. Another period. Halfway between is a midpoint, another period. Halfway between is a midpoint, and then another period, and then a halfway between is a midpoint. So if you want to draw the midline points, you can, but this period's so short that You kind of get the picture. Okay, and I'm just going to draw an arrow that way. All right, so there is our graph. Phase shift, period change, all together in one enchilada, the whole enchilada. All right. I have a couple of examples here for you. I would like you to pause the video. Go ahead and try this example. All right, hopefully you paused the video and tried this example. For this example, again, we had a very, very short period. Our period was 2 pi divided by our 1 over b, which is 4, giving us a period of pi halves. Our amplitude was the absolute value of a, so negative 1, gives us an amplitude of 1. Our midline, our k value, which was y is equal to negative 1. Okay, so we were shifted down 1 unit, so here's your midline. And then our phase shift, we had a c value that was pi fourths, or sorry, just pi. So we went left pi. Remember, it's always the opposite. And then we had to divide by the 1 over b value, which is 4. So we went left pi fourth radians. So very, very similar to our last example, except this one, we just had to shift down 1, and we had a reflection. Okay, here is the next example. Please go ahead, pause the video, and try this example. All right, hopefully you paused the video. Here our period is 2 pi divided by 1/3. So that would be 6 pi, a period of 6 pi. Whoa, very, very big. The amplitude, absolute value of negative 1, which is 1. Our midline, y is equal to k, which is negative 1. And then our phase shift. Phase shift was pi thirds divided by 1 over 3. And a negative, right? Because it's the opposite. So this is negative pi thirds multiplied times 3. And these cancel. So we're just going left pi. I wish it was left 2 pi. That would have helped us, you know, have one easy period. Okay, so if you messed up any of that, please pause the video. Try that. Okay, here is the solution. So since we have a cosine function, we're going to go back pi, and then we have a vertical reflection. Our a value is negative, so I'm starting at a minimum. Okay, and then every 6 pi we repeat. So here at 5 pi, which may have been off your graph. Okay, and then in between is going to be the minimum. Okay, and then there you go. All right. Closure. Here for the function f of x is equal to 5/4 cosine x over 4 minus pi halves minus 3. Explain why the phase shift is not pi half radians. Why is it not? What did the person forget to do? And then determine the correct phase shift. Okay. Hopefully you went ahead and determined that they forgot to divide by the 1 over b value, which is 1/4. So if you divide pi halves by 1/4, what you actually get is a phase shift of 2 pi radians. All right, that is it for this video. Hopefully you learned how to graph with phase shift along with period change. And now you are ready for the full gamut of sine and cosine functions. Hope you learned something. Catch you next time.